Okay, we are continuing with the Algebra 1 benchmark. We are on number 12. This is the third video. 8.6F on number 12 is my TEAC, and this is category 3. Category 3 is linear functions. All right, so I want to show you a strategy. Whenever you see a problem that's this big, you can use the sheets that you tore off from video 1 to look at each line by line if it looks overwhelming. So the length in feet of a small train at an amusement park can be modeled by the function f of c equals 9c plus 14, where c is the number of passengers. So I want to box in my function. C is passenger cars attached to the locomotive. Okay, this is the length, so I know f of c is my length. The whole thing is the length of the car. The original passenger cars were replaced, and the length of the train is now modeled by this. So I see the 9 and the 12 is what changed, but the 14 stayed the same. So which statement describes this change? This is attached to the locomotive. So that means the 14 is the locomotive. So the 14 is the locomotive is 14 feet long. So I know that. The 12 is my slope. The 9 and the 12, that's what changes. The slope is what changes. It says what describes the change. What does the slope represent? If C is the number of passenger cars, what is 9 going to be? 9 should be the length of one passenger car. So the slope is the length of one car. So let's look at these changes. The locomotive is now 9 feet long, and the length of each passenger car remained the same. No. It went from 9 to 12, so I know this is not right anyway. The locomotive is now 12 feet long, and the length of each passenger car remained the same. Each passenger car is the number that changed. The locomotive is 14, so this is where this is wrong. The locomotive did not change. It's the passenger car that changed. So that's what makes these wrong. The locomotive did not change. Stayed 14. Each passenger car, so now this is what changed. It's now 9 feet. No, that's not true. Each passenger car is now 12 feet. Each passenger car is now 12 feet, and the length of the locomotive remained the same. So it's J. (13) 8.10a is my TEAC. This is category 5. Category 5 is quadratics and other nonlinear functions. All right, I have a table of values. It's a quadratic. If 1 is a solution to g of x equals 0, g of x equals 0, what is the other solution? I'm looking for g of x equals 0 on my table. It's right here. So my other solution is 3. Pretty simple. All right, 14. (14) is TEAC 8.7b, and this is category 4. Category 4 is linear equations and inequalities. All right, this is a bubble. A student bought concert tickets online. The total cost C in dollars of T tickets can be found using this function. If the student spent a total of $83, C equals 83. How many tickets did you buy? T is question mark. This is a simple substitute and solve. We're solving for T, we're substituting C for 83. All right, so I'm going to rewrite the original equation. I'm going to get rid of those zeros on the end because they're not necessary. C is 83 equals 24.5 T plus 9.5. This is just a two-step equation. I'm solving for T, so I need to isolate T. Don't be afraid of decimals, you have a calculator. So how do I isolate T? I need to subtract 9.5 from both sides. $83 minus 9.5 is 73.5. This cancels out. Now the second step would be divide both sides by 24.5. And I'm going to get 3. 3 equals T. This is my answer. On a Scantron, in your bubble grid, this is question 14, you would put a positive here and the 3 here, and then you would bubble it in. It's positive 3. All right, 15. This is 8.1D, and the category is 1. This is saying which graph represents this inequality. Well, the first thing I want to do is set this equal to make it look like y equals mx plus b by solving for y. Then I can identify my y-intercept and my slope, and I'll know which one it is. I can also use the calculator to check it. So I'm just going to come right down here in the middle to do my work. To isolate y, I need to move this negative 2x over here. Since it's negative, I'm going to add 2x to both sides. That cancels out. So 3y, put the x in the front, greater than 2x plus 12. Side by side, you cannot combine unlike terms. Now I need to divide everything by 3. So y is greater than, 3 was positive, so I did not have to flip the symbol. 2/3 x, 2/3 is my slope. 12 divided by 3 is 4. I know my y-intercept is 4, and my slope is 2/3. So your slope is 2/3, your y-intercept is 4. For the shading purposes, I know it's going to be a dashed line because I don't have that little bar. So it's dashed. And I also know because it's greater than, it's shaded above. This information lets me know which ones I can eliminate. B and D both have a solid line, so I know it's not B or D. Next, I look at A and B. They both go through 4, and they're both dashed. The difference is the shading. This one is shaded above, this one is shaded below. I know that it's greater than, it's shaded above. A is my answer. You can check it on the calculator by going to y equals, clear that out. Use your arrow to toggle over in front of the y. This is a greater than symbol, so I'm going to hit enter until I have an arrow pointing upward. Use your arrow to go back over, and this is 2/3 x alpha, y equals, to get my fraction, 2, 3, x plus 4. And I'm just going to look at the graph, hit the graph. And I know if I was down to A and C, I would know that A was my answer because it's shaded above. All right, 16. Is 8.2a, that's the TEAC, and this is category 2, which is properties and attributes of functions. This is saying, what is the quadratic parent function? It is y equals x squared. This is something you just have to remember. That's the quadratic one. The linear one, just for the sake of it, is y equals x. Which one is true? What you can do is just go to the graph and look at it. So I'm going to come back over here, go to my y equals, clear that out, and just type x squared. And then hit graph. I want to look at it. This is what the parent function of a quadratic function looks like. Its graph is symmetrical about the x-axis. This is the x-axis. That is not true. Symmetrical about the x-axis would look like this, because that's the x-axis, so I know that's not true. Its graph is symmetrical about the y-axis. Yes, symmetrical means it looks the same on both sides. The y-axis is the line of symmetry. It's kind of like a mirror image. So here's my axis. This is what it looks like. So this is true. The domain is a set of all non-negative numbers. Domain, remember, is your x values. I have some x values that are negative, so this is not true. Its range is a set of all real numbers. My range is my y. That's not true because there are no negative y values. So that's not true. The answer is G. (17) is 8.6b, category 3. Let's see, this graph shows the relationship between the number of cookies a presenter at a convention had left to give away and the number of presentations she had made. So at 0 presentations, she had 180 cookies left over. Then after she did 1 presentation, she had, looks like 150. So she gave away about 30 cookies here. So that's how we can read the graph. Make sure you understand what's going on in your graph. What does the x-intercept of the graph represent? Here's my x-intercept. This means after 6 presentations, she had no more cookies left over. Zero cookies left. Right, so I'm going to read through these to see which one matches what I came up with. The number of cookies the presenter had before making any presentations. This is 180. That would be the y-intercept, not the x-intercept. So it's not A. The maximum number of cookies the presenter gave away. We're not even talking about cookies she gave away. We're talking about cookies she had left during every presentation. So that's not true. The number of presentations the presenter made per hour. This is not even a part of my graph. My grade is presentations and cookies left over. So be aware of that. If they're mentioning stuff that's not even a part of what you're being presented, it's not right. The maximum number of presentations the presenter made before running out of cookies. Running out of cookies means 0 cookies. The maximum number of presentations she made, yes, After 6 presentations, 0 cookies. The max was 6. 60. D is my answer. $18. 8.11b. And this is category 5, quadratics. All right, once again, I have a whole lot of words. I can use my little method to go step by step. A farmer uses a lever to move a large rock. All right, the force required to move the rock varies inversely. Now here's where you need to know your vocabulary. The force varies inversely. If it varied directly, that would mean force equals the other thing. But since it's inversely, that means it's going to be, force is going to be equal to whatever that thing is, it's going to be on the bottom. Distance. So distance has to be on the bottom. That's what that looks like. Varies inversely. What goes on the top? Don't know yet. So from the pivot point to the point the force is applied. Here's my pivot point. Here's the distance. There's the force. A force of 50 pounds applied. So F equals 50. Applied to the lever 36 inches. D is 36. From the pivot point of the lever, we'll move the rock. Which function models the relationship between F, the amount of force applied, and D, the distance? So right now, I have no idea what this number is supposed to be. I do know F and I do know D, so I can figure out what this is supposed to be. All right, so I'm going to substitute F for 50 equals, let's just say this is X for unknown, and D is 36. To solve for X, if I have, since this is a fraction, I'm going to make this a fraction by putting 1 under it. You just cross multiply. 50 times 36 equals to 1x. Use my calculator. 50 times 36 is 1800. So this unknown piece up here is 1800. Force equals 1800 divided by distance. Come over here, that is H. 19. 19 is 8.1b, category 1, functional relationships. Which set of ordered pairs represents y as a function? Here again, this is vocabulary. What is a function? X cannot repeat. If it repeats, it's not a function. So all I got to do over here is look at all the x values. -9, 0, 1, -3. Looks good. -1, 4, -7, -1. Oh, -1 and -1 repeat. That's not going to work. 3, -4, 3, -4. Ah, all of those repeat. Certainly not. 5, 2, 1, 2. The 2 and the 2 repeat. Not. So the answer is A. Last page for this video, number 20. There are 156 laptops and desktop computers in a lab. As soon as I see they're talking about two different things, that can be L, this can be D, I know this is probably going to be a system. So the total computers, L plus D, is 156. There are 8 more laptops than desktops. This is describing my second equation. Remember, for a system, we have 2 equations. So 8 more laptops than desktops. What is the total number of laptops in the lab? I want to know L. Now for this one, you can either do matrix or substitution. I'm going to show substitution, because this right here is equal to L, and I can just substitute this piece for L. So I'm going to rewrite this and put A plus D plus the D equals 156. This is the piece that I substituted. This is the system. Then I'm just going to solve for D. But I want to know L. So after I solve for L, I got to plug it back in. Combine like terms. A plus 2D equals 156. I'm solving for D. So I got to subtract 8 from both sides. Cancels out. 2D is equal to 148. Divide by 2. D is equal to 74. Now, if you put 74 as your answer, that's wrong. It's asking for laptops. So I have to come back up here. L equals 8 plus 74. So L equals 82. This is what you would bubble in. This is your final answer. If you bubbled in 74, that's because you answered the question for desktops instead of laptops. Last problem on this video, number 21. This is 8.9D, category 5. Which statement about the quadratic functions below is false? What I would do is just put all of these in the calculator and look at it. And then kind of draw it. So I'm going to come over here, go to my y equals screen, clear that out. Negative, that is a fraction, alpha. Choose first option. 3 down 4 over arrow x squared plus 6. Hit the down arrow to go to the second one. Negative 2x squared minus 5. Hit the down arrow for the third one. Another fraction, alpha. Choose the first option. 1, 4 x squared plus 1. Once you get them all entered, then you're just going to go to the graph. That's the first one, that's the second one, and that's the third one. What I'm going to do is I'm going to come over here and just kind of sketch that out. So my first one was this one going like this. That was the first one. Then the second one was this one going down like this. It's gone a little lower. And then the last one was like this. Okay? Now these are talking about minimums and maximums. This is a max. That means it has a max point. That's a max. Whenever you talk about parabolas, if it's going downward, that means it has a max. And the reason it goes downward is because the slope is negative. But the last one, the slope is positive. This has a minimum because it's going upward. So let's look at these. The graphs of 2 of these have a minimum. That is false. Only one has a minimum. The graphs of all of these have the same axis of symmetry. This is true. The graphs of 2 of these functions do not cross the x-axis. Here's my x-axis, only one crosses. This is true. The graphs of all of these functions have different y-intercepts. Y, y, y. This is also true. Come back up here, it's asking me which one is false. So the answer is A, because this is the only one that's false. Alright, that is all for this video. This was, I think I started on number 12 through 21.